discussions, but we might have a couple of slides from some of the panelists for these two roundtables that we set up. So we're going to kick off with a roundtable focused on microfab and testbed. So the way I planned this was to have, even though we're going to have, of course, 4 distinguished participants here in the front, they will expose for perhaps a few minutes, several minutes, what they want to convey as a central message. I shared with them some questions and guidelines for this. But after they expose, I would encourage them perhaps to kick off the question session. And they are allowed or invited to even question the previous speakers and sort of engage a discussion with the audience. And of course, everyone else is also invited to join and ask questions. And I would like to make this more of a symmetric interaction rather than audience asking the participants. But the participants themselves are also encouraged to ask questions for the audience or previous speakers that they might want to hear about, or even members from the next table. So I'm going to invite over Cecilia Silva from MackGraphe, Edison Puig from ITA, Claudemir from ELDORADO Institute, and Thiago Alegre from University of Campinas to join us here and do their whatever order they choose to their exposure comments, and then we move on to the discussion. So I would suggest, actually, because Puig and Claudemir do have a couple slides to show, I would suggest they start off, but everybody here, I think, and then maybe for watching the slides is not a good idea. You're totally right. So I would suggest Puig first, and then Coral, and then we get everyone here so everybody can enjoy the slides as well. Thanks.
Thank you, Gustavo. It's a pleasure to be here today. I would like to thank you so much for inviting me. It's the first time in this place also. I've never been here. I am natural born São Paulo guy. No, I was born in Bexiga, and I was raised here. But I never knew about this campus, and it's impressive. It's good. I like it a lot. And the initiative also, I was not following, and I start to follow more closely. And this is the 4th meeting, and it's an honor for me to be here. Let me start talking, telling you that while the slides are being prepared, I was very impressed today with the lectures, the presentations, the talks, and especially those from, I did some mess here. Those from Newton Frateschi, I was very motivated because I think that way, in a way, and Professor Paulo and Sensweig also. Those two are very close to my thoughts, and a great surprise, the presentation of Eduardo Mobilon from CPQD, that is, I told him that is our same approach. So we are thinking very closely about what I will tell you sometime now. Precisa de câmera, alguma coisa assim? Não, ela está aqui.
Para ela não ficar nas perguntas girando, a gente resolveu fixar, então... aí você fica aqui.
Fico aqui. Pode escolher um lugar, a gente fixa em você. Tá. É bom para ver aqui. Okay, so I am from Instituto de Pesquisas, Instituto Aeronáutico, né? Instituto Tecnológico de Aeronáutica, I'm sorry, ITA, that is very famous, everybody knows about. And I started working there in 2018, so I'm kind of new guy there. And we have some developments in quantum technology that I would like to quickly, in 10 minutes, just no more than that, to tell you. So we had this external motivation from the defense sector to start a research initiative, anything we do in quantum technologies. Then this was in 2023. We had many discussions, internal discussions, and decided to invest our time and resources in the area of quantum communication. More specifically, the quantum key distribution that was discussed today, as I just said. So our project, our first project that was the foundation of the lab is composed by all those guys, no? And this is kind of novel in ITA. It's a project, integrated by people from different departments of ITA. It's not very common that at my institution. So we had this goodwill of everybody, and we have people, theoreticians, very good level, with, A1 CNPq position in research grants, some of them, some others level 2 or so. But those theoreticians joined with us at the Electronics Engineering Division, and we had many external collaborations from ITA and from other institutions, and we could conceive this first project. So, I'm sorry, let me see. Let me tell you in this sheet that the lab that is being launched, is being inaugurated, is proposed to be a photonics infrastructure lab for quantum communications and even for other quantum technologies. And we have some plans, immediate plans to perform there. I will tell you in a bit. So our discussion, our planning led to this bottleneck. This is a problem. If you think about quantum communications or quantum key distribution, probably most of you know that you have TRL, high TRL of 8 or 9 in optical communications, in fiber optic, no? In optical fibers. So what the news we receive from the media is that some governments and world-class labs have performed satellite communication. So how Brazil can reach there? No? We can start connecting and getting expertise in quantum key distribution in optical fiber communications, and we're doing that. We're doing that. So I have our developments, our approach is very similar to those of CNPq. But how we can get these connections with aerial platforms, no, mobile platforms. So this is a bottleneck, and we noticed that nobody in Brazil had this expertise. So we quickly started to make some movements in this direction, and our first goal is to have classical communications between aircraft and soil aircraft. Okay, so our program evolved to a program in FSO, that is the acronym for Free Space Optics Communication, and as well as Free Space Optic Communication with quantum key distribution in a very near future. So we are running to get there and working daily in this new lab also. So just as an example, you have some major companies that can supply you with those terminals, optics terminals that you can put in your helicopter or your fighter jets, and they are $1 million each. No? So this is what we are talking, how Brazil can have that. No? And we are trying to nationalize parts, and we are discussing that, we are working on that. And that is, as I said, a necessary step to have quantum key distribution in long distances, not have cable installed. So this is our strategy, as we know, as we see today. We started here. The project is called Infrequent, and we are performing the necessary steps to get exactly where CPKD presented today. So we are going to have this next year. And we are preparing educational programs, a new post-graduation program, and it was already approved, a new graduation program in engineering physics. That is very common. Huh? You have in many other institutions, but we are trying to adapt it to maybe the first. It's not important to be the first, but it can be the first Brazilian quantum engineering program in bachelor. So next, we plan to work in FSO in low altitudes and medium altitudes, and then in steps that includes also quantum key distribution. Okay, so just to finish, as we are going to discuss test beds, what are test beds? Everybody know that are platforms that you can perform experiments and tests aligned with some. I'm reading that because the discussion we are going to have, I think is very important. We have the dictionary definition. So it's aligned with a reference architecture. So standards, international standards, are important in test beds. Where solutions can be deployed and tested in an environment that replicates real-world conditions, replicates. So this is also important, according to the dictionary. And the efficiency, the meaning, how meaningful is a test bed, depends on the target audience. So if academic researchers, developers, decision makers, operational, and support professionals, as you have, you can read that. So we have one, at least one. We have more, but this one is one I like especially. It's a European program that is called Open Key QKD, and it was realized in 2001 to 2003. So it's already finished with great success. So what they did, they have a complete case. We can follow that. They have a test bed, European test bed. So many institutions across Europe were, supported, and this was an articulated effort. So I invite some of you who are interested in this matter to read this successful case of a test, a national, more than a national, continental test bed. And we at ITA, we have this plan and already in action to implement our test bed with the modest goal to attend all 4 kind of publics, no? But because we have that, we have authorities, we have, you know, generals, we have people who decide things, no? We have scientists, and we have partner companies. So we're trying to conceive a test bed who can maybe be a good one for more than one audience. And these are some points I list here for your understanding what we are pointing to. Thank you very much.
My name is Claudemir. I work for ELDORADO, Instituto ELDORADO in Campinas. I am a semiconductor packaging development specialist. And the main program that you have at ELDORADO is development of memories. But I'm here because we are developing a project with Francisco Rochinol. We're together in the program. And the main reason is because ELDORADO has capability ELDORADO has capability to integrate some semiconductor components and with a qubit device. So this, I did prepare any special presentation. Unfortunately, it's in Portuguese. And here is the flow of the equipments that you have, the infrastructure that you have at ELDORADO. In the blue, you can see some grinding, wafer mounter, laser saw, dicing, die separation, optical inspection. This you call die preparation. So we get the wafer from the foundry, and we do the singulation of the die. So that's what we call die preparation. Then we go to the next step, is an inline process. Here we have a die attach process, pressure oven, wire bonding process, testing, flip chip, screen printer, and the pick and place. And in the end of the process, you have a back end, is including the compression mode, ball mounter, reflow, singulation, and the laser writing. And they also have a sputtering that you can do at least two materials, is a copper and stainless steel. And here is some pictures of the process. So we can see the grinding here. The grinding means you can take receive the wafer from the foundry. We do the polishing and the grinding to make the wafer thinner. So in the next step you can see the wafer mounting. Here we prepare, I don't know if you're familiar, but the wafer is prepared for the next step in the ring frame. It's a metal ring frame. We do in this machine here. And laser SDBG is a special process for singulation of the device, the chip. Is the most it's a unique process for wafer processing for semiconductor. And also we have a standard singulation dicing saw. Is a metal blading, diamond metal blading coming this machine. And here we have the same equipment, die separation. Is a very the same design, but use UV and the thermal separation. And the next step, we go to inline process, and you see the die attach. Die attach means you can attach the die on the substrate. It can be organic substrate. It can be a metal. And we have a pressure oven to eliminate any bubble that can comes with this process here. And here is a wire bonding, optical inspection, flip chip process. Flip chip is very common when you replace the wire bonding. Is a high speed. Is for high speed device, and the screen printer and the pick and place work together. This is you dispensing the solder, and you place the components on the place you place the solder. And finally, you have the equipment for the back end. It's a compression mode. Compression mode is for encapsulate the memory, but this you can use for you adapt for different different materials and different components. And here is a ball mounter. You can place the balls underneath of the substrate. Is a very common device when you receive some components. You see some solder balls underneath. You're doing this machine. And here, this machine works together with the ball mounter and the singulation laser writing to identify the components and the sputtering. And ELDORADO has capability to make some reliability and qualification test. You have a shock test, Halt and Has, a stress test chamber goes to minus 40 plus 165 degree, and vibration. Here we are just acquire this equipment. Here is a scanning acoustic tomography to check if the components has any bubbles after encapsulation. And we have X-ray and SEM. Here is a very the components is an example of the components that we have done at ELDORADO. Is a SIP with a stack of dice. We did about 90 stacks of memories with the the solder bump underneath. And here is a PCB board to mount it. And here is the encapsulation. It's a special resin to avoid any mechanical stress and so on. Here is another component that we have done at ELDORADO is a ceramic LTCC. So we have all the components integrated in the substrate. So yeah, here is the same equipment that I'm talking about in the firstly. Yeah, and we have a capability to do some electrical tests and the reliability, as I said. Yeah. Okay.
Okay, now I invite you all to join here, Thiago, Coral, Puig, and Cecilia. And then we follow that approach. I think we can kick off with Cecilia and Thiago making their ponderations, and then we move on to the discussion, right? I'll leave the two mics here.
Okay, so thank you everyone. So thank you, Gustavo, for the invitation. So my name is Thiago Alegre. I'm from the University of Campinas. And I didn't prepare a presentation, but I took some notes of what I think should be discussed here. And just to give you a little background, maybe why I was in this table here. So I've been working with microfabrication for a while, so that's mainly what I would like to discuss here. And I've been visit a couple, actually, 10 different facilities. So CNPAIN, before it was Elenano, I worked there as a PhD with Felix. Felix was there also. Then I moved to Caltech, where they have just inaugurated a microfabrication facility, Kavli Institute. I also visit ENL, which is the Iberian National Nanofabrication Facility. This was a initiative from the MCTI back in 2014 or 15 that we visit there to see if it was possible to do a joint venture. And I'll give you some numbers about it. That's an important part. LMU, I also visit. TMU, TUM, which is the Technical University of Munich. Both has open facilities. The CUNY, City University of New York, which is the largest city university in the United States. So it has like 250,000 students. And they build their own facility, but they share the facility with Columbia University. Stanford University, TU Delft, CSS Nano, that also is one of the open facility. And just to share a number, so we are discussing here, so INL, back 2015, they built a clean room, roughly, I think, the same size as BR Fab, but they built bottom up. They did they only have the ground, they built the building and bought all the equipments. It was a very large facility, and it cost like 250 million euros at that time. And they were seeking partners, but they were seeking partners in a multi-user way. So that's the second thing that I want to point you. I think there's a difference between multi-project way of running a facility and multi-user way. In a multi-user, you allow everyone that has a project to go inside the system and actually use the machines. And I have to say that from the university side and actually from the research side, I see that that's the way that things has to go, because that's where you actually have an amount of people that are working together, even if they are not from the same groups, that can discuss together and actually build up some knowledge and actually partner and propose different things which are not standard. The multi-project way of doing things, we also do this nowadays in our groups, that we basically sit in a computer, draw a structure, and send out to a foundry, which then fabricates it and send it back. But then there's lots of restrictions that do not allow you to do whatever you want or do whatever you think it should be different. And last part before I pass to Cecilia is that this kind of like centered used facility also allows for companies and startups to appear. So I have close relationship with two professors, one in Stanford and the other one in TU Delft, and both got startup packages for a startup, not for the lab itself. And now, for example, Simon and TU Delft, he has 34 employees. And he's been working inside the university's facility for more than 3 years already. What he has now is like he has like his own test bed or test lab for the chips, etc. But he still does the microfabrication inside TU Delft. So TU Delft allows them to come here, to come inside the facility and to work. And it is his employees and not any technician in the facility that does the job. Like he has like couple, I have one student that's working for him now, a second one that's doing like a internship. And it is his employees that goes inside the facility and do the job. So I just want to point this out. I think first like the models around the world are to have a centralized unity in a university or a city. Second, it does not cost, like it is a lot of money that we have to put in and to maintain. So another number, Kavli University, Kavli Institute in Caltech, which is roughly the size as CCS Nano, so it's a small facility. It costs $1.3 million per year to run it. So it is a costly endeavor to keep it. And third, it is that the multi-user approach, I think, is the important thing that you should look at forward. And that allows for the small company to bring together, to get together and actually to have the strength enough to then to go to large-scale facilities and actually multi-project wafer and therefore to scale the production. So I think that's the introduction here. Thank you so much.
Thank you so much, Gustavo, first, for the opportunity to be here today. I am Cecilia Silva. I am a professor and a researcher at the Mackenzie Presbyterian University, and I am here represented the MackGraphe, that is the Mackenzie Institute for Research in Graphene and Nanotechnology. And this is a kind of not so new center because you are almost 10 years from we opened the doors in 2016. And inside of MackGraphe, you have a clean room that is around 162 meters square, class 100 and 1,000. I don't have a so big journey as Thiago, but since my PhD, I was working in clean room facilities at CCS Nano and after at Rutgers University, United States, thinking in how you can integrate two-dimensional materials and microelectronics and sensors. And when I moved to MackGraphe 10 years ago, the goal of our center when you're thinking about open clean room facilities is to give the opportunity to the users a place that you can manipulate the two-dimensional materials like graphene or TMDs that usually is acting as a contaminant in the CMOS conventional clean room. So in our facilities right now, we are able to do the grow of 2D materials like CVD or TMD in general, but it's a facility that you can manipulate and do all the transfer process in the conventional circuits and do photolithography, metal deposition, reactive ion etching, and now you have also dicing process and also packaging. You can also have a wiring bonder. It's possible to process inside of the clean room. So when you think about the MackGraphe facilities, is also a multi-user lab since 2 years ago when there were one project from FINEP that was pushing some amplification in clean room laboratories around Brazil, and it was receiving some funding. So our facilities is totally open for users from Brazil and abroad also, without any kind of a cost. But when you start thinking about these clean room facilities as a place to receive users that submitted a project, it could do running your projects inside of the laboratory, as Thiago said before. Then you can also promote the integration between students and other researchers from our community. But also you would like to think in this clean room, this laboratory, as a place to pushing research more for the innovation point of view with small companies, to be a place that they could also develop your own projects in sensors, main sensing areas. You think we know all the difficulty regarding semiconductors companies in Brazil. Is very poor, but when you think about start new concepts and also innovation in this sector, you needed to offer laboratories that the new entrepreneurs and these new small companies could use. So MackGraphe has this kind of vision when you're thinking about our facilities. This is something that we really would like to be in the near future. I think the goal of the invitation of Gustavo and be here in this event, I'm very happy to be here today and know more about the research that the colleagues around the different parts of Brazil is doing in quantum sensing and also devices. You see how you can collaborate and discuss about what kind of infrastructure you have and what you can offer and what you can thinking about the applying joint projects together in a kind of acting a kind of a consortium between the different institutions around not only São Paulo but also Brazil, to promote this real integration about the people in this field. So thank you so much.
You have the right to kick off questions as being there, so.
We have the right.
You have the right to do it, yeah.
Okay, so maybe I can start. And so I think we've been running these meetings for, I think that's the fourth time that we have meetings about the idea of have this quantum community to grow up. And we've been laying down even the fundamentals, and then today is basically about the facilities and the test beds. And what I would like to understand, maybe from the colleagues here, from the audience, is if we should focus on local facilities or more like a centralized facility for some of the things. So, for example, I think in the case for the ITA and CPQ deal, you guys are sort of looking for the same approach, but on the other hand, it's still complementary because you were also looking more to aircraft and so on. So I don't think that there is a talk that can be between each other, but maybe it's not easy to make just a single facility. And for Eldorado, I've been there for a couple of times already, and all the fabrication facility there, I don't see that it's possible to open for researchers, not all the steps. So maybe one or the other step, but there are part there which is like a 100 class facility, which is not possible even to enter there. When I was there, it's like you cannot go inside because you need to make the standards and quality check periodically. So we see that there's like, on the other hand, we have like the university, which has we have our own small clean room on our lab. We have CCS Nano, but it's still like scattered. So how we will bring this thing together and actually do the next step in this community? So it's an open question. So.
In this way, in this area, we received a set of questions that Gustavo prepared. Everybody received that set of questions? Okay. So I answered each one. I will not read now, but they are answered. I can send you after. But it's good for training what I think about those things. So I know I think something. And I detected, answering, that there is a fake discussion. Should we centralize things? Should we avoid redundancy? So this, in principle, is pointing in a good direction, no? But it depends. It depends what you're talking about. No? If you're talking about sending Brazilians to the moon, okay. No, if you're talking about, you know, an electron accelerator like the synchrotron light, if you're thinking about a nuclear reactor such as the Brazilian reactor that is being built, okay, no, okay, you're right. It's a huge endeavor, but if you're talking about, you know, quantum communication equipment, I am kind of old, so I remember the time when having a CPA system like ultra-short pulse with many millijoules or joules, no, it could be at that time discussed if should be centralized. Everybody bought those. Geologists bought, no, people who work in many areas, but because it became a tool. No? It was quickly noticed that that was a new tool. So that is, in many points, you cannot discuss quantum technologies. It's not one thing. No, you have different TRL, different sizes and complexities. So for sure, many of these new technologies should be dispersed, in my view. Should be, because people must have contact with this across Brazil, must have high education programs and so, and many labs are needed. And in other cases, I don't know, maybe a national quantum computer facility should be centralized. So you should be careful with those, you know, easy proposals and, you know, discriminate things. I think, just to add what you just said, I think the problem is not redundancy, the problem is not dispersed resources, nothing that. It depends. No? It's not something we can state in principle. The problem, in my view, is dispersed management. Dispersed, you know, some things should be agglutinated, should be concentrated in a program that everybody takes a part, everybody participates, but has some centralized goals. I really believe in that. So we have this new program maybe starting soon in quantum sensors, and this is a huge national program, and I think everybody is welcome to contribute, but it has a policy. In some cases, I agree this a good solution is the only one for Brazil, but in other cases, not. Many people, just to finish, many people used to ask me, oh, people in Rio de Janeiro are doing the Rio Quântica. Why are you doing that, Anita? So it's not a good question to do, no? It's not even polite. But yeah, I think so. I know the people from Rio de Janeiro. I know them personally. I know what they're doing. And we are doing another thing. Another thing. And every time we get together, I talk with them about that. People in Salvador are doing also quantum communication. And now I knew a great project in CPQD. So there is one in São Carlos, there is one in Pernambuco, there's lots of programs, and they do not necessarily overlap. On the contrary, they make things happen quicker in Brazil, and this is a good thing.
I think maybe have a different point of view is regarding, for example, you know, the difficulties to not you start a new facility. I think our most hard part is the resources to keeping the equipments running all the time, and resources for that is poor most of the time because our funding agents is very difficult when you open a call just for you having maintenance in your equipment. So this is the most difficult part when you have sometimes several equipments around Brazil, but sometimes just one or two of these equipments is working at the time because the others don't have a resource. So we have the equipment, we receive the investment, we'd like to do this locally, but after you don't have enough conditions to keeping the equipment running. So because this sometimes I have more the view that is necessary, you let a different, some institution that with strong capacity in different fields, and you have more funding to financing the students moving across these institutions for using these facilities and receiving the trainings from researchers and technicians that is residing in these facilities. In my point of view, this really also push for collaborations, because sometimes when you have our small facility in our institution, we are thinking to do everything there, and you lose the opportunity to interact with other researchers and know other research groups and do things differently from your own institution. I think this is a point, but in this case, I think it's really necessary you have a network. We know that it's possible you enter in the website of PNIP and see what is the equipment, but we need to create a kind of a platform that everybody can enter in a website and see what is the, not only equipment, but what this research group is doing in quantum technology opportunities. Oh, this institution is really strong and more in synthesized materials that has interesting application in quantum technology, so this could be a future partner for us. I think this kind of a platform or website, you can put in everybody together with, you can show what's the best strong field in your institution, your laboratory, what you can collaborate. I think this is really important. We start to promote it because this, we don't really necessarily some funding to start to do this kind of thinking. Share more about what we're doing in a website, and you can see in creating the connection between the institutions. Mm-hmm.
Yeah, in fact, Eldorado is difficult. Is not completely open. Yeah. But I'll give you an example. We have two machines in the wafer preparation. Mm-hmm. Is a back grinding and the laser dicing. Mm-hmm. To be a specialist and operate the machine took about 1 year. So it's very difficult. We are open to make a service for the community. Sometimes Unicamp come to us and oh, you can do some grinding and the dicing. We are open to do that. So as a service, yeah. But our main concern is about maintenance and training. because if you have a special program for maintenance and training, you'll be fine. But otherwise, the equipment you'll be on the side and nobody can use it. So that's the main issue in my point of view.
Yeah, I think just one comment. So I think maybe Puig is looking for the test bed side, and maybe like we are looking from the microfabrication side. As you mentioned, I think not every single infrastructure needs to be centralized. But what I was mentioned maybe is that, okay, if you have a service, it is very specific service and a very determined, and therefore with a very specific quality. For that, I think you were right. We should have services. But when you're saying like to develop something new or to actually to research something new, you need to have the time for the person to actually to look for it and to learn about it and to work on that. This is a problem, and I still don't know how to face it nationally, as you were mentioning, or to bring it, because I don't know anybody who started to do a microfabrication and was successful before 4 months. So the guy goes inside the facility and stays there every single or every 2 other day, and still needs like 4 months to be trained, to understand what's going on, to know how to operate all the machines. So in that sense, I agree with you. That's but again, I think the question that Gustavo, I will read because I was provoked by Puig. He mentioned like, okay, so what are the main problems that we have for the basic research, and how we can actually prototype until we get a quantum devices? I think for the basic research, it is a centralized facility because you need to propose something which is new, which is not done by other places. And even materials, I think Gustavo mentioned that. In CSS Nano, we fabricate not only gallium arsenide, but also diamond. There's not a foundry for diamond. So if you think about like these two different materials than silicon nitride, it is difficult to find a foundry. But graphene cannot enter on CMOS facility. So any foundry in the world, none of the foundries in the world will say to you, okay, send me your flakes of graphene and I will put it there. No, it will destroy the CMOS facility. So in that sense, I think a multi-user facility, it is necessary to go forward. And this needs to be open, I agree. We always like pointing Marcelo, saying, so FAPESP is not like doing their job, but we need to point also to our institutions, because every single equipment that comes to Unicamp, there is a signed commitment saying, we will pay for the maintenance throughout the project. And this is not done in the university. We need to say that aloud. The universities need to take like their part, say like, look, if you are bringing a $3 million equipment like Newton got for the CCS, why the university cannot pay or the maintenance for like 4 years? So that needs to be put on the table also. And it's very difficult. So, but then I will point back to FAPESP, because I think that's very difficult to be done from the researcher sides. Because once we are applying for a project, we need that signature. And since we didn't got the money yet, it's very difficult to do any bargain with the university. So in that sense, I think FAPESP, it is in the position to say, okay, I will only give you the money if you do this. So because FAPESP has the same power as universities to push forward. So anyway, so I mix a little bit like the things here, but maybe the audience wants to comment. And today, Marcelo, unfortunately, is in the bad role of like being pointed out every time. But I think this needs to be decided.
Okay, so it's not a question, but it may be a question, you know. we don't have an ecosystem. Like, for instance, one of this e-beam system that Thiago just mentioned, if you go to Boston, probably there's like 5 or 6 machines like that. Then it's much cheaper for them, and actually they're going to have somebody sitting there to do the maintenance of the equipment. In some cases, the companies even they lend the equipment as a, I don't know, it's a way of making a case about using that equipment as a good solution for industry. So we don't have this. Plus, our system of importation and our borders are very complicated. It would be better if you would pay importation taxes, in my opinion. I don't think you gain anything. I mean, it would be much more efficient if we pay like a given flat fee for importing everything. We didn't have to go through all this trouble to go to this importation without paying for the taxes. Then also, the same problem affects the companies. We did this work looking for hardware startups. It's a big deal importing parts, components to make things. So some of the companies that succeeded, they do, in Brazil, what's cheap is doing design. So do design here because this is cheaper, then you pay less for people here than you pay in the United States and Europe. But whenever you talk about doing things, real things, and that's many cases, you can only be competitive in terms of global market if you do things, if you improve your materials, improve your components. And that's the part we have a problem. So, in my opinion, the only solution for this, at least for making a bit easier getting the components to replace and training people, because that's the big, sometimes it takes like 1 year for you to get a mass flow controller. And without a mass flow controller, a etcher will not work. And if that etcher does not work, unless you have like 2, the serial part of making a process is interrupted. Once it's interrupted, it's not good for anybody, so you stop doing anything that you're doing. So all the other equipment become a little bit also not usable because usually you need a chain of processes. So we should fight for some, I don't know if you have the strength for this. If you want to do quantum technology, perhaps like at Viracopos, for instance, a free channel for research, as long as it's research, innovation, the free channel for buying consumables and importation, also making it easier. I think we should do, that's the only solution for that. Second thing, once you have material and you have stuff that you can buy more easily, together with every time you do like a multi-user or a large equipment, there should be a commitment for a given amount of money, like we have for a scholarship or something, for traveling, for paying people for coming doing the research, and also for the, what is it called? As long as the equipment is under warranty, it works fine. So it's a problem about buying parts, by doing the importation, sending sometimes equipment to be fixed out. There's something easy anywhere, but here is a big deal. And the third thing is being able to create this ecosystem. So if you have more than one equipment, several equipments of the same type from the same company, would be great to have like a machine shop. I don't know, some representative from that company, because it's much more expensive, right? I'm sure in Boston there's somebody working for some of the companies for the e-beam systems. In Brazil, for instance, what's the name for this, for microscope, electron microscope? GEO. We have so many of the GEOs that we have maintenance in Brazil. So, but it was going to take some time. And in order to get to that point, to train the engineers and everything, the other part should be easier. And you know what I'm saying? Perhaps in the program we should fight for a free channel or some sort of, if you need to go the way we're doing, for the startups it doesn't work, and for the research it doesn't work. I mean, I don't know if you agree, and if you think we should come up with a document that should ask for this type of thing, otherwise I don't see it working.
Yeah, just said.
Yeah, what I want to say is along the same lines as Newton, and but there's one other thing that maybe I should add. In addition to all the difficulties in importing things and servicing and everything, I mean, we all know, right, this equipment will break. It's not a good use, bad use, they will break, right? And what we have been noticing is that the companies, I mean, the service has degraded over recent years, you know. So Bruker, for instance, has left the country. I mean, they just left salespeople, and sometimes the salespeople need to deal with some maintenance too. So we are in a terrible state, I would say, right? So I think in this context, the new, I agree with Newton. Maybe we should, you know, have some political pressure over companies, especially companies that have many equipment in the country. But in the present state, I would say redundancy is good, right? Because if we have one equipment here, another identical one in Rio and somewhere else, then we know that at least when this one breaks, the other one maybe I can use, right? And finally, just one final thing is, again, the thing about servicing, the funding for, you know, maintenance, especially not the fixing maintenance, but the maintenance while I don't know the name. Yeah, maintenance contract. So this is very difficult to get from funding agencies in general, not FAPES or FINEP is the same. So it's very, very difficult, and this is crucial. And again, handing the responsibility to the university is a difficult thing, because then the university may say, okay, wait a minute. So if you want to you know, buy a very big equipment, the expensive equipment, maybe we should decide centrally, is the priority a biology equipment, or is it a chemistry? So you start competing with other departments within the university. So I don't think it's fair, you know. You think?
I need to keep pushing. I think it's good. I think the university needs to mature to the position that they take the decision. If they don't have the money to keep up with all the equipment, then you have to prioritize. That needs to be in your future plans. It's bad if you lose. I know that. And physics in general lose because it's difficult to convince, because of biology and medicine, as we have at Unicamp. But on the other hand, if you think about like an institution, if you cannot run all the equipments, why will you buy it? It's a very difficult, I might be like shooting my feet here, but that's what I truly believe as a contributor to a taxpayer person. If you don't know what you are doing, then what you are doing.
So just to complement, just to add, hello. So just to add, lots of problems were discussed, or a few of them were discussed just now. One of them is the import problem, you know, the taxes, the exemptional taxes. And as I know, I'm asking the audience, as I know, just Brazil has this, you know, this quota, this CNPq amount, maximum amount. I think no other developed country has that, and so some foreigners, colleagues, used to to tease us that it's a Brazilian ugly thing. It's jabuticaba. No? But this is one thing. This we must fight against it. This is clear. No? The defense sector has not, a ceiling, not a quota. Many other sectors has, but the science and technology has. So we must fight for it. Is maybe first priority, thing to concern about. But this is not the main thing here. This is just one mention. I just want to add that I recently got very impressed with something I didn't know. That is the Senai Cimatec in Salvador. Do the audience know what I'm talking? The Senai in Salvador, the Cimatec. So they have a very different model that just works, as I know. And I've been there 3 times just last year, and for 1-2 day visits, or 3 days in one occasion. So they receive real world challenges or proposals from companies, from other agencies, and they have a way to receive and do the operational things necessary, and they have technological industrial parks that can have equipment, those kind of equipments we are discussing here. You're right, it's not what I was talking before, but I think their model, it's one thing Brazil tried and got it right, I think. So we could maybe have in São Paulo, because we don't have in São Paulo nothing similar to what we have in Salvador now. So this is maybe a way to have quantum technology, and they are doing that. So we can use this, the Cimatec initiatives, but we can have one in São Paulo, one in Rio, and they have employees that are contracted by, they're hired by the Senai, but they are part of the project, so they are paid by the companies. They have shared human resources. Mainly, I remember, I know this, one example I know, but I was told there are others there, in data centers for high performance computing. They have shared human resources. So it's an example that can be maybe applied to this discussion.
Hello, everybody. My name is Felipe Barbosa. I'm a professor also at Unicamp. And although I don't have the experience in a lot of clean rooms like Thiago, but I work roughly 2 years in CNF, in the microfabrication facility from Cornell, integrated photonics. And I'm roughly 1 year in CUNY as well, and I've been using CCS Nano for the better part of the last 3 years. After the pandemic, we started using very heavily. And the point is, what I want to bring is, bring back to this point that Thiago brought, right? Because this table is really heterogeneous. One thing is microfabrication, and a completely different thing is test beds. And it, depending on how you want to do your quantum devices, if you want to develop quantum devices, if you want to develop quantum technology for maybe eventually bringing to market, you have to also develop devices. That's something that I have in my mind, that you can work on systems, right? You can pick up the devices that are already working and build systems on top of it. But research and device, I don't think it's I think it's even more important than production. If you think about the United States, they kept doing research in the quantum, not quantum device, just classical devices, right? Even though they stopped doing production few years ago, right? Like few decades ago. So that it's a question is like a comment, and it parts not only from what I think that should happen, like as a Brazilian citizen, but also as a researcher working in quantum devices or trying to work in quantum devices here in Brazil and being beaten up by the lack of adequate clean room equipment. And I think that is the most important thing for quantum devices, to actually do the devices, to have a multi-user open facility. It could be in São Paulo, it could be in Rio, it could be in Manaus, it doesn't matter. It just matters that you can access and use it. And as far as I know, it's a pity that Rodrigo Capaz, maybe he's here on the call, I don't know, but for me, it's not clear what if BR Fab will be this facility, because you need, in order to fulfill this role, you have to be able to welcome the users, train the users, have a public agenda. It's the users have to be able to work on the machines, and not everything should be multi-user facility. I agree. I was actually talking during lunch with some people about that. Sometimes you don't have multi-user facility. You don't want the guy that fix your car to use a multi-user facility. You have to be someone who knows what they're doing and are working there to make the best product possible. But if you are doing research and development in that level of the device, you have to have a multi-user facility, because if you don't, you just can't progress. You just will be attached to whatever the foundries, the companies can. So it's something that if BR Fab will not be that, we need a plan. We need a way, a path to have. And I would like that to be in the state of São Paulo, because it's where I'm based. But without that, I think that is very hard for quantum technology to progress. And I want to make just another comment, that the way I see the clean room is like, it's like a computer, right? The lithography is the processor, the memory is the etcher, and the clean room, that's the most important, is the motherboard. If you have just the processor, it's not good, and it's not a computer. Just the memory is not a computer. Just the hard drive is not a computer. But that's everything together in the motherboard, and not just physically together, but organized together. Rodrigo showed us a picture of CNF, but the most important thing about CNF, and I say that as someone that worked there, is the organization, is the fact that when I came there, I have never entered a clean room in my life. And 1 month later, I was doing devices. 6 months later, I was like one of the experts in one of the lithography machine that we use. Like someone that people ask questions about when they have a problem on the machine. So it's in this sense, it's something that is very transformational. You can pick up like a bunch of machines that is used in the industry and do something that the industry cannot do, and maybe feed the industry back with the technology that you develop. So basically, that's the question/comment.
Given that you mentioned BFAB, Rodrigo, if you're hearing us, do you want to take a...
Yes, I want to comment on that. Thank you, Felipe, for the comments. Right on the point I was going to make. We are still discussing the operation and system of BRFab, but it's already clear that it cannot be the same as the current facility that LN Nano has, because if you have a larger number of users, it's important that not all equipment is operated only by the staff. So you need to be able to train people and have trained users to use the equipment as well. But we also think that that's not true for all projects and all equipment. We're going to work in the direction of more hybrid system, especially in the case of CMOS. In the case of CMOS, if you have very sensitive projects, I believe we're going in the direction to have our staff operating the equipment. But this is still under discussion, and your input is very good, Felipe. So we're definitely considering having a hybrid system, as you mentioned.
Thanks.
Very good, Marcelo.
I have some comments to do. One is related to the problem we have to the maintenance of the equipment. I know FAPESP has no money for this. Sometimes you need to ask for some money, but it's depending on the value of this maintenance, it's also sometimes different. So there, I see two different ways to do that. One is the community start to demand this to FAPESP. For example, every year we have a call for maintenance. It should be one way. It's not possible in my view, my point of view. It's not possible to have one open source, one open way that you can ask everywhere, anytime. It's impossible. It's from the point of view of yeah, it's impossible. This is one way. The second way, I have been looking for the problems with the companies from this last year, and I see two main things. One, and for me it's quite important, is the fact that sometimes the researcher wants to buy an equipment, and I don't know why, but he wants that one. But the problem is, when you look around and start to ask for other colleagues that has the same equipment, you see that the company has a very big problem, a big issue when they need to give some maintenance. The price is high, the assistance is terrible, so, and the researcher insists in buy that equipment. This is a problem. I have been say this in FAPESP, but they said to me, you cannot say this. It is not a problem of FAPESP, it's a problem of the researcher. Once you buy the equipment, FAPESP, it's co-responsible because the money, this is a public money. So FAPESP is co-responsible for this. But it's not a decision from FAPESP which equipment it will be bought. Okay? And so this is one thing. But another thing that I see it's frequently now, you can negotiate. All companies, I would say 80 to 90% of the companies, they have a share, huge share, and you can negotiate. Many companies give up to 50% of discount to not lose a sale. So you can negotiate 5, 6 years of maintenance inside this before to buy the equipment. But it's not, of course they will say, I cannot do this. Okay, you say, I will not buy your equipment. They will negotiate to not lose. So it's quite common, and I hope they don't listen. But it happens a lot of times, and with many companies, you can negotiate it. So it's something that it's a mindset we need to change in the researchers also. Because they want the equipment. The guy arrived, I have the money. How much you have? $1 million. Oh, it's okay, I have the money. I buy them. And you can negotiate it. You can have all these things inside the same price. So this is something that I think I'm now talking as a researcher. I'm doing that also. Yeah. Yeah, no, yes, in the call it's not allowed. But you can negotiate it and you can put this inside the price. You will not appear. And there is another thing, so just a comment. I think we could think about delocalize. This is something that we have no money to do here in Brazil. We have a scholarship to send our students abroad, but we cannot send our students 6 months to another state. If you have different facilities with complementary facilities, We could send one PhD student to another state to pass 6 months, 1 year, and train him. Because I don't know what's the size of this community. Is it huge enough to for example, to justify 3 million reais to build a very, very big facility just to work on this? So I think we need to train people. And this could be one possibility, to delocalize the students, okay? To really train them in different facilities across Brazil, and then when you have that very critical mass of people work on this, we can make demands a little bit higher. I don't know, this is just a point of view, but
I would like to make 2 short comments. One about the facility, the BR facility at CNPM, CNPM. We lost an opportunity when Sirius was built to have more graduate students participating in the construction of the accelerator. This is something I discussed with Antonio Zerroque at the time. We should have had an army of students working closely, because so many solutions, so many local solutions had to be devised and were devised. And it's just, we would have a generation of more people with the kind of knowledge that went into building Sirius. We shouldn't make the same kind of mistake with facilities, with any kind of fabrication and testing facility. It's very important for graduate students to be able to really do what Felipe said, get into the facility, get into the clean room, and with very little time be up to speed and eventually be one of the experts running certain machines. So this is extremely important. Second observation is about the decisiveness of researchers in choosing their equipments. There is no such thing as a FAPESP law. There are regulations within FAPESP, and regulations, yeah, but there are no specific laws, and that means that FAPESP has to understand what is being said by Marcelo here. Obviously, people who are working in FAPESP, they have the responsibility of telling a researcher, the equipment you want to buy is an equipment that we've had a history of issues with the company, with poor maintenance, with poor technical assistance. So not a good deal. And that's something that is the responsibility of people in FAPESP to share that knowledge with researchers and say, you want that, you won't have it, or if you do, don't count on FAPESP for any kind of funding for maintenance, because we know that it's not going to work well. Other thing, you mentioned negotiating. There are lots of opportunities, not only for negotiating with companies on new pieces of equipment, but used pieces of equipment and refurbished pieces of equipment. And again, this is something that researchers worldwide have access to, makes their lives a lot easier. We need to be able to have our lives made easier just the same way. So this is something that from within and from outside, it's our responsibility as a community to force the hand of our funding agencies, of our local and federal governments to change the way things are done. It won't change if we don't push for it.
So just to, in the interest of logistics here, it's 3:30 now. We were supposed to finish at 3:20, 10 minutes ago, and there's another roundtable to go. And to add on that, Bruna warned me that ICTP bought food for us. I'm not sure if anyone is hungry at this time. If you want to stop for a snack, there is food.
Coffee, come on.
I wasn't expecting.
So can I make a very quick and final comment, if I may?
Yeah, sure.
2 minutes, really, sorry. Very quick. Addressing the point that Paulo raised, I agree completely. Although a synchrotron light source is very different in complexity as compared to a fabrication center. But nevertheless, I didn't have time to present in my 15 minutes, but we also considering that there's an instrumentation branch of the development of BR Fab that we are working on. And we are planning to develop within CENIPEN things that are very simple, such as furnaces, but also something that is very complex, which is an ion implantation, an ion implanter. So, we already have in our budget, our proposed budget, scholarships for students to be involved in the development of this equipment. This is one thing. The other thing, very quickly, that I would like to address, I don't know, maybe Thiago mentioned, is again, a fabrication center is not as singular as a synchrotron light source, in the sense that we do not expect to have just one centralized facility, a fabrication facility in Brazil, in a country as big as Brazil. So in our discussions with the ministry, we're already also discussing that these different clean rooms that we have spread all over Brazil, they could be a part of a network, but it's important that some degree of management should be the same, or at least equally efficient of all these facilities, so that this coordination really works. So I just wanted to add those 2 points, and sorry for postponing the meal.
No, thanks, Rodrigo. That was a great comment. Let me take my role as host here and just add a 1-minute comment on that. First, Felipe pointed CNF. I know several researchers in the US, either based in Columbia University or Rochester University, and even in Michigan. They graduated the CNF. They still go back to CNF to produce silicon nitride wafers. So CNF, even in Europe, I met a person now that goes back to CNF to get silicon nitride wafers. So there are some niche developments that occur at a given facility that facility will be known and talented for that particular process, and people will be willing to travel to that place just to get that particular process carried out. And just to go on the lines of having a national network, as Rodrigo pointed, I think one of the things we should do, haven't been done as far as I know, is to organize so that we know what are the key core competencies of each facility. Maybe MackGraphe want to stick to the 2D materials along with FMG. Maybe, I don't know, CCS is going to be the first 100 kV electron beam lithography in South America. Okay, so this is a $3 million tool. It's not cheap. Maintenance cost, if you hire the contract, is $100K a year. So, we need to identify those so that in future investments, we keep the spins aligned. I think what have been happening, and myself and Thiago followed this with FMG back in the day, right? People just started buying things, oh, there's money, oh, let's buy an etcher, let's buy this, let's buy that. And I would say, I think the only etcher, ICP etchers working in Brazil right now, maybe is one at CCS. And we have probably 4 or 5, ICP-RE, right? The ICP-RE etcher, I think it's one, and again, there's one in São Paulo, there's one in Minas, there's one, it's not to blame them, it's just that there are many tricks to get those things running. So if we were to identify those common grounds and share even knowledge how to fix them, because we learned a lot along the way, that those downtimes would be reduced. So I think this is one takeaway from all this comment and what we need to put forth this organization. Maybe in São Paulo State, at least, FAPESP could play a leading role in that process and to steer the community. I agree with Paulo. FAPESP should say, Felipe Curtel bought one of these lasers. He also paid $200,000 and it's dumped. And FAPESP knew that internally. Somehow, somewhere in the importation process, FAPESP had a history with that company that you, because didn't know the history, bought a second laser, and now you talk everywhere in the world, people say, I had the same issue. and the company went bankrupt. M squared, by the way. Anyway, so just we can have a short break. If people are hungry, can have the lunch. If not, can just have maybe a coffee, and then we come back for the cryo session and eventually go home. Okay, thanks a lot. It was a very nice discussion.